Jai Hind, myself Pushkal Kumar Shukla, Assistant Professor, Computer Science and Engineering Department, Ajay Kumar Garg Engineering College, Ghaziabad. Today, I will discuss about the function and classification of function. Before knowing function, we have to familiar with set theory and relations. So, in earlier class, we have studied set theory. Basically, what is set? Discussed already. So, set is a well-defined collection of distinct objects of a similar type. For example, vowels of English alphabet like A, E, I, O, U. Suppose we take even natural number. So, even natural number is also a set. Even odd natural number is also a set. Prime number is also a set. Now, come on the relation. What is the relation? So, relation basically, let A and B are the two sets, then relation R from set A to set B is defined as relation R is a subset of A Cartesian product B. For example, suppose set A has m elements and B has n elements. So, Cartesian product A Cartesian product B is defined as m and n elements, and it is a order pairs actually. So, total number of relations will be 2 k power mn. It is a subset of A Cartesian product B. So, R is a subset of A Cartesian product B. So, A and B having mn elements, A and B having mn order pairs. So, relation will be a subset of A Cartesian product B. So, 2 k power mn. Now, come on the topic function definition. Here we will discuss about the function definition, classification of function, operation on function, growth of function. The student will be able to use the composition of logarithms and the floor or ceiling function to solve problems. They will familiar with the floor and the ceiling function. They will familiar with the function sequence for various choices of a recursive function definition. They will familiar mathematical introduction to prove that a given sequence that reaches one of the several cycles or not. So, these are the objective to study about the function. So, the prerequisite, the basic understanding of the class 12 mathematics NCERT and basic understanding of set theory and relation. Now, what is function? So, function is defined, it is a mapping in which every element of set A is uniquely set A. It is a mapping in which every element of set A is uniquely associated with the element with set B. We can define function as let A and B are the two sets. Then function is defined from A to B and written as f A to B. If all the elements of A are related to the elements of B, all the elements of A, this is the elements of A, all the elements of A are related to the elements of B. And second condition is all the elements of A has one and only one image, unique image in set B. Just for example, this is set A and this is set B. The elements are A1, A2, A3. This is B1, B2, B3. So, elements of all the elements of this are related to this and only one image, yani unique image they have. So, here all the elements are related and A1 have only one image B1, A2 has only one image B2, A3 has only one image B3. Next example, A1, A2, A3, A4. B1, B2, B3. This is not the function because all the element of set A is not associated with the element of set B. So, this is not a function. This is also not a function. A1, A2, A3, B1, B2, B3. This is also not a function because A2 has two images, B2 and B3. This is not a unique one and only one image. All the element of set A has one and only one image. Here A2 has two images, B2 and B3. So, this is not a function. This is not a function. Domain of a function. Let f be a function from P to Q. Suppose this is a P, this is a P and this is a Q. And this is a suppose function. For example, here we will see let P and Q are the function. Sorry, P and Q are the sets and f is the function from P to Q. Then this is known as the domain. Yani element of this P1, P2, P3 and this is Q1, Q2, Q3. So, this is the domain part. This is the domain part. So, domain of this function, domain of function is P1, P2, P3 and codomain is Q1, Q2, Q3. This is the codomain. The element of set Q is the codomain of function and the element of set P is the domain of function f. And now the question is what is the range? So, range, this is the range that is the part of the codomain, which having pre-image, the element which have a pre-image, the element of set P. Yani here Q1, Q2, Q3 are the range of the function and also Q1, Q2, Q3 also the codomain of the function. So, we can say here range is subset of codomain here. Yeah, always, but here range is equal to codomain. So, the range of the function is the set of the pictures of its domain. In other words, we can say it is a subset of its codomain. Range is a subset of codomain. For example, here set A and set B are there. 1, 2, 3, 4, 5. These are the elements of the domain of F. The domain of F is 1, 2, 3, 4, 5 and codomain is A, B, C, D or E. And range is the elements of B which having a pre-image in the element of set A. So, here A, B, C, D, E all are the elements of the range and we conclude a range is a subset of codomain. Now, come on this example. Find the domain, codomain and range of the function. Let x equal to 1, 2, 3, 4, 1, 2, 3, 4, y equal to a, b, c, d, e and function is given 1b, 2a, 3d, 4c. So, here the domain is 1, 2, 3, 4, 1, 2, 3, 4. The codomain is a, b, c, d, e and range is a, b, c, d. Range is a, b, c, d. Now, some important terms related to the function. Suppose given a function from a to b, this is a and this is b and this is a function f, a to b. So, elements of set A is suppose A and elements of set B is B. So, we can say that this is having elements A and this B equal to that is function of A. Yani A and B are associated under the function f, under the image f. So we can say ki b is a function of a. So like this. So given a function f a to b, a is called, this is called the domain, this is the called codomain. F is a mapping from a to b and written as b equal to fa. Then b here is called the image of a, and a is called the pre-image of b, like this. Now come on the classification types of function. So different types of the function we have to study. First is an injective one-to-one function. A function in which one element of set A, one element of domain set is connected to one element of codomain set. So here we say, suppose this is set A and this is set B, and function is defined like this. So one element of set A is related with one element of set B. So A is related with 4, B is related with 5, C is related with 2, and D is related. So one element of set A is connected with one element of set B. So we can say it is one function, या injective function. One function, या injective function. One function, yeah, this is also known as injective. Here we see here, A is associated with 1, B is associated with 2, C is associated with 3. So this is also the example of one injective function. The most important thing we have to remember for solving the problem related with the one-to-one function, the necessary condition to be a one-one is if x1 equal to not x2, this imply fx1 equal to not fx2. Yeah, fx1 equal to fx2, this imply x1 equal to x2. The question may be asked many times. This question may be asked, this question is asked in AKGEC examination, so that fx equal to x cube plus 2 is 1 1. Then how to prove it, how to solve it? So let us assume fx1 equal to fx2. So function is given as fx equal to x cube plus 2. So this will be 3x1 cube plus 2 equal to 3x2 cube plus 2. 2 is cancel out. This imply 3x1 cube equal to 3x2 cube. 3 cancel out. This imply x1 cube equal to x2 cube. This imply x1 equal to x2. So let us we assume fx1 equal to fx2 and we conclude x1 equal to x2. So this is the example of one-to-one injective function. Another example we see, suppose fx equal to x square plus 2. So fx1 equal to fx2. So this will be x1 square plus 2 equal to x2 square plus 2, 2 cancel out, and x1 equal to plus minus x2. So condition is not going to hold. If fx1 equal to fx2, this imply x1 equal to x2, then it will be 1 1. Here x1 equal to plus minus x2 is coming. So it is not a 1 1. It is not an injective. Now come on the surjective function, yeah, onto function. A function in which every element of the codomain having pre-image in the element of domain. Here A and B are the two sets, and here all the elements of B, that is A, B, C, having pre-image in element of set A. So this is the case of the surjective function. Now bijective. What is bijective? This is also known as 1 1 on 2. A function is said to be bijective if it is 1 1 and on 2. 1 1 means injective and on 2 means surjective. It means both should be there, 1 1 and on 2. It means ki all the element of set P is one to one connected with element of set Q, and for on 2 all the element of set Q has associated with, has pre-image in element of set P. So here all the element of set Q A, B, X having pre-image in set Q, set P. So it is on 2. So a function is said to be bijective 1 to 1 if it is 1 1 and on 2 both. Into function. So into function, a function in which there must be at least one element which having no pre-image in set A. So here A, B, C are the element of set A, and 1, 2, 3, 4 are element of set B. So here 4 is the element in set B that having no pre-image in element of set A. No pre-image, have no pre-image in the element of set A. So this is the case of into function. This is the example. Consider this example, 1 1 into function. 1 1 into function, a function is 1 1 and into. Both condition will be applied to be a function 1 1 and into. 1 to 1 connected, and there must be at least one element in this which having no pre-image from this element. Many one function. Let f x to y, the function f is said to be many one function if there exists two or more than two different elements in x having the same image in y. So here two elements, two or more than two. So here elements 1 and 2 having same image. Yeah, 1, 2, 3 having same image, that is x. So this is the case of the many one function. This is the case of the many one function. Here 1, 2, 3, 3 elements in the set x having related with element of set y. Same. So this is the case of many one function. Many one into function. This is the example of many one into function. It means ki jo more than two elements of set x having same image in element of set y, and there is at least one element, that is 2, having no pre-image in the element of set x. So this is the example of many one into function. Many one onto function, same functions is said to be many one onto if it is a many one and onto. Both conditions is going to applied here. Many one, it means ki more than two or more than two elements of set x having a same image in the element of set y, and all the element of set y have a pre-image in the element of set x. So operation with the function. Now operation on a function. So different operations are there that are applied on the function. Add function. So here suppose f(x) is equal to 4x minus 5 and g(x) is equal to 2x. So addition of function will be performed and written as f plus g x, written as this, and this can be written as fx plus gx. This equal to the function fx equal to 4x minus 5 plus gx equal to 2x. So this will be 6x minus 5. Subtraction operation on the function. Suppose fx equal to 4x minus 5 and gx equal to 2x. So subtraction f minus gx, this is written as this f minus gx, and this will be also written as fx minus gx. Fx equal to 4x minus 5, so right here gx equal to 2x and minus is there, so write minus. So 4x minus 2x, that is 2x and minus 5. So this is the way to calculate subtraction between the two functions. Multiply function. So fx equal to 4x minus 5 and gx equal to 2x. So multiply of the two functions f dot gx, yani fx dot gx, yani ki 4x minus 5 dot 2x, yani 8x square. This will be 8x square minus 10x. So this is the way to calculate the multiply function. So very important. There is a difference between the composition of the function and the multiplication of the function. Multiplication of a function, suppose we write fogx. So this will be the composition of the function. This is not f dot gx. So composition is a different operation, and this is the multiplication. This is the multiplication operation, and this is not equal actually. Both are different. So here we are talking about the multiplication of the function, and this is the composition of the function. Now question is how to calculate this fogx. So here I am going to calculate fog. So fog of x equal to f of g of x equal to gx is what? Gx is 2x. So write here f of 2x gx, and fx is 2x minus 5. So put this value in this. So this is f4 into 2x minus 5, that is 8x minus 5, 8x minus 5, and this is f dot g. So this is not equal here, this is not equal. So we can say this is not the same operation. This is not the same operation. Now come on the divide function. Divide. Suppose fx equal to 4x minus 5 and gx equal to 2x. Very simple. Divide f divide gx, and this will be written as fx divided by gx equal to 4x minus 5 divided by 2x. And this is the, again condition is going to apply it, x equal to not 0 in this case. This is the inverse function. Let f be a bijection function from a to b. F be a bijection function from a to b. Then the inverse of f, denoted by f inverse, is the function from b to a. Suppose this is a and this is b. A function is defined, this function is defined from a to b. So f inverse b defined from b to a, like this. This is f, so this will be f inverse. And f inverse possible if the function is bijective. Bijective property hold, then in this case inverse function is going to calculate, otherwise not. And bijective means 1 1 and 2. If function is 1 1 on 2, then it is bijective. It having property of injective as well as surjective, then it is bijective. I mean, if it is not bijective, then at any cost you are not going to calculate a inverse function of it. The first and foremost important condition to calculate inverse of a function is a function must be bijective, No inverse exists unless f is a bijection. Example, let f be the function from a b c. This is function defined as from A to B 1 2 3, fa equal to 2, fb equal to 3, fc equal to 1, like this. Is f invertible, and so what is the inverses? So definitely it is 1 1 function and all 2 also. So inverse exists, and f inverse 1 equal to this C, f inverse 2 equal to A, and f inverse 3 equal to B, like this.